We have actually seen some pretty sophisticated code using recursion. Now you might think, well, recursion is also doing calculation in steps. Well, yes, but those steps are split across multiple copies of the same function. And what we are now going to see is this very powerful idea called iteration, and sometimes called looping, where we will do all the calculations within just one copy of the function. So to show you this, I'm going to take you to our favorite example of a recursive function calculating x to the power n. So let's look at this piece of code and focus on the case when n is positive, because that's where all the interesting calculations happen. So let's suppose we are talking about a case when n is positive. So we come to line 2, we find out that n indeed is positive, and then we go into the if condition, line 3, and that's where we make a recursive call to the power function, but this time with the second argument, n minus 1. And what will happen? We will make a second copy of the power function where the parameter n is now 1 smaller. And in that copy of the power function, again, we will check if n is greater than 0. So you see that we are repeatedly going to be checking if n is greater than 0. We have this if condition, if n greater than 0 on line 2, but we are doing this check multiple times. Of course, we are doing this check in different copies of the same function, and now we want to do everything in the same function. So to do that, in C, we have to change the if condition to a while condition. So the way to read this is while, or as long as n is greater than 0, do these steps. And when you have finished doing these steps, come back, loop back to this condition and check it again. And if it's still true, again do the steps. So when will we stop this process? Well, we will stop this process when n is no longer greater than 0. So when we look at the code, the recursive code, we see that each time the recursive call is made, the value of n keeps decreasing by 1. Now we have to do exactly the same thing in our while loop. Obviously, if we don't change the value of n, and n was positive to begin with, then we will come into the while loop, we will do the steps, the value of n won't change, we'll come back to the top, and again n will be positive, and then we will have an infinite loop. So we will have to decrease the value of n inside the while loop, inside this same function. And we do this using a very, very important type of statement called an assignment statement. Now, when you read this sentence mathematically, it makes no sense. We cannot have a variable equal to the same variable minus 1 in mathematics. But this is not testing for equality. This is using single equal to, which is an assignment statement. And the way to read this assignment statement is the new value of the variable n is the current value of n minus 1. So in general, when we have an assignment statement, we always have a variable on the left-hand side and some expression on the right-hand side. And we always evaluate the right-hand side first. Now, in this case, the expression on the right-hand side, n minus 1, has the same variable n which appears on the left-hand side. And this is perfectly fine. So we calculate the right-hand side using the current value of n, and then the result of that whole expression we store back into n. So the value of n changes. So I know this kind of a statement is very, very strange to get comfortable with, but we have to try and understand this because it is a critical type of statement that we will now start seeing. So once again, it says the new value of n is the current value of n minus 1, and this achieves the same as decreasing the value of n, which we did in the recursion. Now, when we are calculating these powers of x, we are doing a multiplication on line 3 of the recursive function. But if you think about it very carefully, when we're inside a call to the power function, we are multiplying x by the result of the recursive call. So whatever answer that has produced, we are then multiplying it with x. So we are calculating in, let us say, a temporary variable, the result of the previous calculation times x, and then we are returning that value. So now that we have to do everything in steps, we need to make that temporary variable explicit. We have to explicitly talk about that calculation so that we can show these powers of x accumulating. So we need to have a new variable that will accumulate these answers. So the way we do that is, before the while loop, we declare this variable ans. We'll just call it ans because it means answer. And so this statement double ans or double ans is declaring the variable answer. Now inside the while loop, we have a new assignment statement. And once again, the way to read this is, the new value of ans is the current value of ans times x. So each time we are doing this body of the while loop, we are multiplying the current value of ans by x. And so this ans variable is accumulating the overall answer. Now, when the while loop has finished, you see that after the while loop, we have return ans. This will be the final answer that we are going to return. So this is almost the correct code. We are missing something very, very important. Remember, I said that when we have variables in C, they are uninitialized. So if you look at the statement inside the while loop, the first statement is the new value of ans is the current value of ans times x. Well, what is the current value of ans the first time? Well, it would be whatever value was stored inside the variable ans to begin with. Well, when we declared the variable ans, we didn't give it a value. It is uninitialized. And that is not correct. We will end up with a bad calculation. So we need to look at our recursive code and figure out what should the initial value of this calculation be. And it turns out for that you have to look at the base case, which is line 4, n equal to 0. And if n is equal to 0, on line 5, we return the value 1. So we're going to use that value in our declaration of ans. We're going to say double ans is initialized to the value 1.0. So we're not simply declaring the variable ans, we are declaring it and giving it an initial value. Now, as far as possible, we should do this for every variable. Whenever we declare it, we should try and initialize its value right then and there, as we have seen in this variable ans. Now, sometimes it's not possible to initialize those the values of some variables, but we should try and avoid this, because as programmers we can forget, and if we forget, then our calculation may be incorrect, and we will see some examples of this. So anyway, we are able to take this while loop now and replace our recursive code with this code. Now this code is almost perfectly the same as the original code, but not quite. And I want you to think about this, and we will discuss this in the next video.